Ladies and gentlemen, what have we here? Well, it's from England. It wasn't cheap. I got it on eBay, and I am opening it. Very high expectations. Here we have some parts. A interesting tidbit of information. And what do you know? That looks uncannily like a KIM. Here's a KIM. Here's what we're going to be looking at. More very detailed instructions. This is actually pretty good, because when we're placing the components on this KIM, will this much be easier. And what I really like is he's using the same yellow colored you know, so it's not only a clone, but it's a replica, and that's nice. I mean, I have clones. That's a clone. It's an excellent clone. PAL1. I have the Quartium. That is an excellent, powerful clone. And as well, there's the Quartium. Beautiful, beautiful, excellent. It's got like 32K memory. This the PAL had 5K memory, but it's expandable. The thing about those two is they're not drop-in replacements for. They're not drop-in replacements. They are clones, and they're excellent clones, but they are not replicas. And this is what we're replicating right here, a KIM-1. So let's keep going. So far, we've got some laminated component placement documents. Try to keep the reflection off here. More information about the TTY board. This will be very helpful, I think. Oh, and look, very helpful. Well, I mean, if you can't figure out where these chips go, you're in big trouble. But here we go. This is going to be great for the capacitors. Let's take a look at this. You're about to see what I mean when I say drop-in replacement. Okay. This is what we're building. Compare it to this. It is a drop-in replacement. It will be not just a fully functional KIM clone. It will be from a distance or even close up will be indistinguishable. And in terms of mounting brackets and size and basically aesthetic feel, it will be indistinguishable as well. So I'm really looking forward to this. What else do we have here? We've got parts, more parts. These are the switches, toggle switches, tactile switches, faceplate. I am curious to see how this faceplate's going to work out. There's the faceplate. So we compare that to this. Oh, they do line up rather, like I said, drop in replacement. Look how they line up. Let's see. Pretty close. I have a case for one of my KIM-1s that I want to put this in when I'm done. I'll show you. And I think we're going to be fine. There's plenty of room above and below. But when we're done, I am going to see if this truly is a drop-in replacement by seeing how this will fit in the KIM-1 case. So what else we have here? Okay, here's all our chips. A couple of 6532s, 6502, RAM. Oh, here's the RAM. I'm sorry, ROM. Is that a ROM? I guess it has to be. Let's see. Are these the same? Yes, these are. The same. They're actually, the digits are a little larger, but the which is nice, but the case is the same size, so that's exciting. Everything's going to be socketed, so that's nice. Very often on the original KIMs, things were not socketed, especially the memory, and so troubleshooting was always difficult, but this is socketed. Let's see. Yeah, 2816 EEPROM. That was this guy right here. 6502 CPU, 2 riots, LM311, which is a I think it's an op amp. The NE556 is a basically a double 555, an NE565, I don't know what that is. 74125 is a buffer. 7438, 7406, Max 232 is going to be, oh, the Max 232 is on the board. Oh, no, it's not on the board. Max 232 has got to be on this this little expander board, because the original KIM did not have the Max 232, and the Max 232 just changes the voltage levels from TTL to RS232. 374 LSO4s, which are just I believe those are NAND gates or AND gates. 7400, or either NAND or AND gates. 74145 and 138. Again, one is a buffer and the other I'll have to look up what that is. 8 RAM chips, 2102. Those were probably hard to come by. And then 6 of the MAN 178 with 71, which is the 7-segment displays. A bunch of sockets. There you go. All right. Well, I'm going to start assembling this, and I'll start by placing the components on the board and then soldering them in place. And I'll place all the sockets in, and that'll be the easiest, is the sockets, and then I'll start doing the capacitors and stuff. So let me get this started. I'm going to pause the camera for now. Okay, so already I'm finding that this chart's going to be very useful, because it's showing me where pin 1 is on the sockets, and the sockets, because they're the easiest to install and probably the most soldering, I'm going to start going. So anyway, the notch is going to be on the side with pin 1, and this says pin 1 is there, so the notch is going this way. Fold over 2 pins, lock it in place. Meanwhile, the soldering iron is firing up. Okay, so U1, which is probably the CPU, has the, if you look, it's got the notch facing, shall we say, east. So, which is, by the way, that's the way it is on the KIM. The riot chips face an opposite direction. Okay, so U3 and U2 are facing west. So far I haven't had to straighten any pins out or everything. Everything was packaged with care. Alright, so now I've got, let's see, this is 1, 2, 3, 4, 5, 6, and that's a 14 pin. There's a 4 pin. So I've got, and then I've got 1, 2, 3, 4, 16 pins, and 1, 2, 3, 4, 5, 6, 18 pins. 1, 2, 3, 4, 5, 6, 7. No, those are 16. 1, 2, 3, 4, 5, 6, 7. Okay, 14 pin and 16 pins, 8 on each side, 7 on each side. Do I have any other ones? No. So, well, it'll be pretty easy to figure out where to put the. This is that op amp. Goes here, and U28 faces up north, I guess you could call it. And the RAM chips are 16s. Let's take a look. They're all facing east. So they're all going to be like that. Should be 8 of them. 2, 3, 4, 5, 6, 7, 8. Okay. Get those 8 in there real quick. Flip this over, lock a pin on each one of these. When I start soldering these, I'm just going to solder 2 pins, then I'm going to come up, flip it, 2 pins on each one, then I'm going to flip this over and make sure it didn't slip out of place, so all of these are sitting flush, because it'd be even a millimeter of not sitting flush would just look awful. And after all, these are you know, if you build something, you want to make it look good. Somebody took the time to went out of their way to design a KIM-1 replica that is very authentic looking, and we should take the time to assemble it correctly. U13 and U14 are facing south. Nope, sorry, U13 and 14 are 14 pin sockets. Okay. 1, 2, 3, 4. That looks like a also 14-pin socket. I should pay attention. So that's U17 facing south. Okay, there's the transistors, resistors, those will be easy. U29, 7. U29 faces north. U30 faces north. You know, if you put the socket in backwards, it's not a big deal. U31, if you put the socket in backwards, I mean, you could, I mean, it doesn't mean you have to put the the IC in backwards, but so that notch is U24 faces south. That notch is just there for human convenience. It's got nothing to do with actual functionality. U16 and U15 face north. 1, 2, 3. These are 1, 2, 3, 4, 5, 6, 7. So they're 14 pins. Facing north. And later on, when you're populating these sockets, I mean, you know, it's nice to have to be able to look at the notch and know that you know, if you knew that you did it right to begin with, then you don't have to go back and figure out which way that your IC should face. But U27 faces north. U4 faces north. Did I finally get one with a pin that I have to straighten out? Nope, nope, it's just me not being... Come on, come on. It's because I'm trying to fit a 16-pin socket into a 14-pin. Let's see. Okay, there we go. Get these 3 locked in. All right. Here we go. U25 and U26 face south. Alright, let's see, it must be getting near the end here. Do I have extras? Yes. I have an extra 18 pin and an extra, sorry, extra 16 pin and an extra 14 pin. That was kind of them. All right, anyway, I've had the soldering iron warming up behind us all this time, so we should get ready to solder. Just want to make sure I've got plenty of space to work with, so I'm not yanking on this cord. Okay. And like I said earlier, I'm just going to for each one of these, I'm gonna solder the two opposing pins. Then I'm going to flip the board over and make sure nothing slipped out of the place and it looks crooked, because it would be embarrassing. And if you've soldered all of the pins on, it's just that much harder to fix your mistake. So let's see. There we go. I'm debating with myself whether or not I should just show this at like 10x speed or something with some music in the background, or what, or you guys can listen to me jabberjaw. But you know, I really enjoy soldering. I find it gives me a little bit of a zen, especially on quality boards such as this. You can tell somebody's taken the time to create something. What's it say in the back here? It says, I don't know if we can focus well enough. It says, I think it says Devilish Design, KIM-1 reproduction. Is that focusing? No. Anyway. Alright, so now we got her flipped over. Let me flip her over and make sure these are all straight. No, there's a couple I'm going to need to fix. You can see that. Start with this guy. Just needed a, yeah. I don't think this one needed anything. No, that's flush. You just warm it up and you can feel if put some pressure on this side, and if it moves. Alright, well those are all good. Let's see how. Let me try this one here. None of those moved, they're fine. All the big sockets are good. These guys look good. Warm them up anyway, give them a little push just to see. Yeah, that one budged. That one did not budge. Alright, looks like the memory, they all look pretty darn good. Okay, so let's finish soldering these. And I've said it a million times, the soldering, it's all about time and temperature. And I suppose having a clean tip on a nice hot iron that you can regulate the heat on. So some people pay a lot of money for super good solder. I've been satisfied with the same brand of solder I've been using for years. It's Wizzo 6040. I find the I don't know, if there's better solder out there, I don't know what could be better about it. It's just solder. I do wish the of course I like having flux core solder, but that just means you have to clean up on some boards. You got to clean that flux up to make it look nice, or in some cases even function. But I think the way it's going down here, we're going to be okay. I don't think I'm going to be scrubbing the back of this board, because the solder is taken to the pads just fine, and I'm using only as much solder as I need. So I don't think we're going to be dealing with a lot of extra flux after fact. Sometimes I find that cleaning the flux just spreads it around, and so you have this kind of waxy goo that you dissolved in alcohol when you cleaned it, and then it just managed to recongeal just all over the place, and you get like this streaky, dull colored board instead of those nice, beautiful, bright solder joints like in the old days when the solder had more lead in it. But what are you going to do? Yeah, they don't put as the solder's lead free now, or at least mostly, and which is great. But the old days, the lead solder had a much better finished look to it when you were done. It was brighter and shinier and all that. This solder is what it's like, well, no, it's got lead in it. 6040 PB is lead, right? So yeah, it's there. But and again, you don't use you wouldn't use lead plumbing, leaded solder in plumbing. So if you're ever sweating pipes, oops, a little bridge there. That's because my tip was getting dirty. If you ever sweating pipes, make sure you don't use your electronic solder. Don't use any lead on water pipes. So that means you got to buy the silver stuff. Costs a little more, but causes a lot less brain damage. Let's see. The other thing is, you see these puffs of smoke. That is not lead. Not puffs of lead. Lead boils at 900 degrees. Alexa, what's the boiling point of lead?
Lead's boiling point is 3,180.2 degrees Fahrenheit.
Okay, I'm sorry. Lead's boiling point is 3,182 degrees Fahrenheit. So you're not getting this off-gassing of smoke that you're seeing is just from the flux, which is basically tree sap, and kind of has a nice incense smell to it. I mean, if it irritates you, then you could put a fan up. I just never found it necessary. But then, if it does cause brain damage, that would explain a few things. But alrighty, moving along here. Again, time and temperature. Don't use too much, but use enough. You got to push it down in that hole just a little bit. I got to tell you, when you're trying to find your soldering mistakes, it's easy to find a bridge, but it's very hard to train your eyes to look for spots that that don't have enough solder or something like that, because at least in my case, your eyes kind of wander around a little, and it's hard to focus on those little dots, and you could overlook very easily something that you had overlooked before, and you put together a board and it's not functioning or it's intermittent, and flip it over and look for some cold solder joints, or joints that look like they were soldered but maybe didn't quite have enough, or joints that were just skipped. I've seen it. I've had people send me stuff and couldn't figure out why it didn't work, and the first thing I did was flip it over and look at the solder joints. Would you believe that more often I'm finding people who don't use enough solder as opposed to people who use too much, which I thought would be more prevalent, but nope. Let's see. And I think you'll find, like, if you're not using enough solder on your joints, one of the complaints you'll have is that it kind of works, but it doesn't, or it works intermittently, or it works if I press here on the board, something like that. And that's an indication that you need to go and like reflow those, check all those joints, and then just warm up and reflow any of them that you are suspicious of. Moving along, moving. So the KIM-1 came out, what, 1977? What else came out in 77? Let's see, the Star Wars movie, the first one, that was about 77, right? Actually, Alexa, what year did the KIM-1 come out?
Here's something I found on the web. According to jakearchibald.com, the KIM-1 came to market in 1976.
Oh, okay. Yeah, she's right. 76. The Commodore PET came in 77. So, it didn't take them but a year. So that's interesting. But they kept on making KIMs all the way up into the early 80s. So, then after that, they were making Sims and AIM 65s and all that, and so there was still plenty of demand for these single board computers that were programmed with a hex pad, and I don't see a lot of actually I don't see any literature out there that would be for students, like a something you'd buy in a college bookstore. Instead, I just see the user manual and the programmer's manual and all that. So I don't think, it wasn't marketed for students to use the way like an SDK would be for 8085 college students, maybe electrical engineers or learning programming or who knows what. But so I'm not sure after, I'm not really sure. I mean, I guess industrial controllers or just people, hobbyists and stuff like that, were buying these things, as opposed to, that's why SDKs are everywhere and they're easy to come by, because that was something that was required in college classrooms for your engineering students. So they still got their they had to assemble it, and they probably sold all their books back to the bookstore, but kept their SDKs, and 30 years later they're selling them on eBay for $100 because they're abundant, and there's plenty of literature out there for them for students. They're let's see, there's a good example of one that almost didn't get soldered well. So but I mean, if you want to learn machine language, I mean, you can do it on an emulator, or you can do it on a computer, like a VIC-20 or an Atari and all that stuff, and you have. But what's going to happen is, it's like you're going to learn machine language a lot faster programming a hex pad on one of the on a KIM than you will using a computer that's already got BASIC and loaded, and you can install a cartridge or ROMs for assembly language and all that stuff. None of that here. This is bare metal programming, and that's a thing of beauty. And it doesn't take long that you can compile small programs on a piece of paper or in your head even. You just need to know. You just need to know your codes. I mean, load accumulator is A9, store accumulator is 85 if you're doing it on page 0. You just know these things. Let's see, 4C is a jump for subroutine, and then 40 is just a jump. You got to know these things, or you could just print out the opcodes on a piece of paper and use them look as a lookup, but pretty quick you'll find you're not looking them up anymore, and the crutch you had, which was that print all those opcodes, you might return to it occasionally, but for the most part you're compiling in your head. And that's great. So I think, let's see, let's warm those up. Go down. Make sure they all flow good. Yep. I think those are perfect. All right, what I'm going to do now, they're all soldered up. Not bad. What I'm going to do now is probably put the resistors in. I'm going to hit pause while I do that. I'm unhitting pause right now because I just want to tell you how impressed I am with the packaging of the parts. There's a USB stick in here. I wonder what's on that. Probably manuals, but I mean, pack 1, it's got diodes and resistors. Pack 2, it's got diodes and resistors. Pack 3, it's got diodes and transistors and resistors. And then pack 4, it's got our crystal, cap, and a couple resistors and transistors. So this one's got the little switch caps. No biggie, nothing to see here. We're going to do that last anyway. There's the switches. There's a bunch of capacitors, and then there's the rheostat for adjusting the tape volume, which you should only have to adjust once ever and never touch. We'll do this one last. This is the add-on card for power and TTY. I don't, for testing, I'll just, you just need power. I'll just use this thing that I got laying around. So already wired. Power KIM. I should have probably paid attention to find out what was on this 1 gigabyte memory stick. Probably important. Okay, so I don't know. Let's go with pack 1, right? I mean, he wouldn't have labeled it pack 1 unless he wanted me to do it first, right? So I find this interesting because I'm not used to doing this by like color coding, you know, in the sense that, I mean, like you just have to match it up with the picture. It doesn't even tell you, you know, the silk screen is not really labeled with what you're putting in there and stuff like that. So you just go by the picture, which is fine. Just used to doing it with a silk screen. That's all. So look, we've got our diode. Oh, you can't see. All right. I'm holding the diode, and their diode goes right there. If you look on here, it shows that the diode, the negative side is this way, so the positive side is that way, so it's going to go like this. The picture's not terribly clear, but there it is. Okay. In you go, buddy. All right, diode in. Why is that diode there? Oh, the crystal. Oh, that's not crystal. I'm sorry, crystal's way over here. It's a cap of some sort. But let's see. Okay, so now we've got orange, red. Orange, red with a gold band. I don't have all that memorized, but you don't have to. Orange, red with a gold band. It's already done. I think orange is 3, so is that 3, 3, and then the red is I should look this up, but to memorize that stuff in 8th grade electronics. I can't believe I still don't remember. So orange is 3, 3, and the red is let's see, black is 0. I think red is 2. So 3300. So that's 3,300 ohms. I'm dying of dying of curiosity. Could Google it, or I could just break out the ohmmeter and see if I'm right. 3, 3 is orange, and then the red is a 2, so it's a 3, 3 with 2 zeros. 3,300. So stick this on 20,000. Let's see if I'm right. 3.23. So yeah, that is correct. 3,230, but you know, these things are gold band means it's within 5%. So that's okay. So 3 of those. And the OCD in me makes them all point the same way. Otherwise, I would be, I don't know, it would bother me if they weren't all pointing the same way. And I think, you know, resistors are not polarized in any way, but I still. All right, do we have any other 3,300s? I think not. I think this is an extra, but let's just go through the list here. Look for an orange. Oh, there's a sorry, a yellow, more orange. I'm sorry, orange, red. Way down here. Make sure I get this right. Okay. Perfect. Okay. So next, here's a one-off. Oh goodness, we're going to be going through this. Okay, yellow, purple, black, gold. Tell me what that is. Yellow, purple, black, gold. Okay, so the black, the yellow, and the purple are the first two digits. The multiplier is the black, which is basically a 0, or like a. So this is 47 ohms, 46.9 ohms. So yellow is 4, and purple must be 5 or 6. Okay. So where do you go, Mr. 47 ohm resistor? Not labeled. See, they got. Let's see. I'm just gonna have to look. Yellow, purple, black. Well, let's go back to pack 1. Pack 2, pack 4, pack 3. Where'd pack 1 go? Let's see. We could look at pack 1 and see what resistor number it was, but big dummy me, I must have tossed the, alright, whatever. Alright. I'll have to rewind later and find out what I did with that, the label for pack 1. Yellow, purple, black. It's the one-off. Where are you? Yellow, purple, black. Way down here. Next to right here. Okay. Cool. All right. Oh, so what do we got here? We got brown, which is 1, black, which is 0, and red, which is 2. So 1 0 with 2 more zeros is 1,000. That is correct. I don't even need to check that. Okay, so 1,000. Okay, so brown, black, red. Looks like we got 6 of them right here. Let's see, 7. Oh, they're around. Okay, so brown, black, red. 1,000. So your current 1,000 is, it's a current limiter. Probably going straight to the base of the transistor. One end is probably going straight to the base of the transistor, and the other end is going straight to the riot chips. Data line pins, probably. I like these resistors. They're not cheapy with the super floppy wires. Their wires got some gauge to them, so that's good and stiff. I mean, what did I just do? Did I get this? Okay, gold. The last two. See, again, there's my OCD. I should just call it OC because I don't consider it a disorder to want things in the right place. So it's my OC. Okay, all facing the right way, and I've got them in the right spots. As long as I'm here, red, black, which is 220. Get some 220s in here. Do we have any? No, they must be in another bag. So we'll have to circle back to those later, of course. Okay. So let's see. We got gold. Well, actually, it's gray. Looks like it's gray, red, black, gold, which is, they go right here. 1, 2, 3, 4 of those. And then 2 more, that's 5 and 6. And over here, so red, black. The multiplier is black, so that's a just a 0. So gray and red. I don't know what gray is, but red is 2. So let's just stick it on 200 ohms and see what gray, red, black 0 is. Let's see. 80. I want to say 82. We're looking, put that up so you can see it too. It's either 80 or 82. So, well, the 2 is the red, so gray must be 8. It ain't rocket science. So 82 ohm resistors are going 1, 2, 3, 4, and then 5, 6, and might even be a 7th one. I'll go back and double check that. One of these days I'll go back and look at these resistors on the schematic and see what they're supposed to be doing. But when you think about it, 1, 2, 3, 1, 2, 3, well, so these 6 obviously control the 6, the multiplexing for the 6 digits, but the what do those ones do? I don't know. You see they're coming right down here. Oh, they're 1, 2, 3, 4, 5. Oh, that, you know what they are? 6, 7. It's a 7 segment display. So the 82 ohms are just current limiters for the LEDs inside the 7-segment displays. Why they're all not neat and tidy in the same row, why it's like 4 and then a 2 and a 1. It's interesting, but I guess that's just the way. Let's see. Well, he was. Oh, there's pack 1. Let me know. So yeah, he's being true to form. See, look, there's the 1, 2, 3, 4, 5, 6, 7 7-segment display. 1, 2, 3, 4, 5, 6 go into the base of these transistors. 6 transistors. 1, 2, 3, 4, 5, 6. So this is there's your 7-segment display, and interesting. It's coming. So this must be the latch for the 7-segment display, and this is how they're multiplexed. So you see this going into there. So this has something to do with the multiplexing, or it's a decoder of some sort. One of these days I'll look that up. Found pack 1. All right. 47 and 82 ohms. Yeah, we nailed those. All right. 12 of these 1Ks. Let's see where the other, and then 2 of these 47,000s. Just double check those. You got yeah, so 47,000. It's easy. We don't need, so we know that 4 is yellow. We know that 7 is purple, and the multiplier is orange, which is 3. 47000, 47,000. So and those are so they're not really again, the only way we're going to know where they're placed, because this just has the resistor numbers, and this just, we know it's 47. This just tells me that there's 2 of them in the bag. So we just got to do an eyeball hunt to find out where these 47,000 ones go. So we're looking for yellow, purple, orange. So here's yellow, purple, orange. There's 1, 2 of them right there. That puts them, these 2, again, assuming you can see what I'm doing, is these 2 right here. All right, so that's the yellow, purple, oranges. Let's see. Got those guys in. Underside of the board's starting to look a little wiry. I don't think I'm going to start soldering until I got more resistors in, or at least all of pack 1 done. So what's remaining of pack 1 is 1, 2, 3, 4, 5, 6 1,000 ohm resistors. So and 1,000 ohm resistor is brown, black, red. So look for, okay, there's oh, it's 2 brown, black, reds, 1 here, 1 there. That's 2 of them. Again, I like the stiff, thick wires, not the cheap. These are the not the cheap ones. I just lose a 1K resistor. Don't do that to me. Well, hopefully it'll turn up. Alrighty. Look for some more 1K resistors. Brown, black, red, brown, black, red. They're going right here. Okay. Make sure I get that right. All right. So that, let's see, we've got at least one more 1K resistor plus the one that I dropped and rolled away. Not the end of the world. I have tons of 1K resistors laying around. It's just, okay, let's see, find another brown, black, red. Here's a brown, black, red. Right there, brown, black, red. Here. That is correct. Let's solder those puppies up before I open another bag up. Alrighty. Mm-hmm. Mm-hmm. Okie dokie. Get the snippers and the lifters. Get all these guys pointing straight up so they're easy to snip and hopefully uniform. Okay. Oh. Okay. Nice flush cut, but not too flush. Yeah, you don't want to cut it, I mean, totally flush with the PCB, because you'd be cutting a lot of solder away, and you need that little blob of solder on there, and so just So I'm making sure there's at least a little bit of sticking out. I am not cutting flush. I mean, they all called flush cutters, but I'm make sure there's a good bump there still. It's all right. Let's see. Magnet, clean all that up. Thank you. Again, not looking too bad. Wouldn't call it professional, but it's you know, I can reflow any of these that look like you know, that look I don't know, what's the word, snaggly. So just reflow the ones you cut, and the snaggly ones will look a little better. I don't know if snaggly is a word, but you know what I mean. Okay. All right. Let's see. That was pack 1. Pack 2. 2 diodes. 2.2K. So that's going to be red, 2.2 thousand. So it's going to be red. It's going to be a 2.2K. Let's see, 560 ohms. It's going to be 5. What do we say 5 was? 5 was like purple, I think, and then 6 is whatever 6 is, and then 0 is black. So then a resistor 5.1 million and 10Ks, 5 10Ks. Well, 10K is going to be brown, black, orange. Okay, let's see if I know what I'm talking about. All right, red. Those are your two 2.2Ks. Brown, black, orange. Okay, so that's your 10Ks. There's your 2 diodes. These must be well, the 5.1 is okay. So 5 must be green. Okay, so 5, and then brown, which is 1, and then 5 more zeros. So that would be 5 1. There's a lot of zeros with 5 zeros. Yeah, so 5 with 6 zeros is 5 meg, and this is a and this is a 5 1 with 5 zeros. Yeah, let's do that one first. Where the hell does that one go? Let's see. I mean, for God's sake, 5 million ohms. Let's see. I got no. That's a so I want to look for green, brown, green. Green, brown, green. Green, blue, green, green, blue, green. Lots of green, blue, greens. Those are the. Look at that. No, that's green, blue, green. Green, blue, green. Lots of green, blue, greens. Let's see. Let's flip her over. Not up top. Oh, what's this? Green, no. Green. Green, brown, green. There she is, right above that op amp. Right here. Green, brown, green. Okie doke. In you go. Okay, so there's that. 560 ohms. That's the okay, so green is 5, then 6 is blue, and 1 is brown. 560. Okay, so they're all, let's make sure there's no 560s up top. There aren't. They're all 1K, 10Ks, and 330s. All right, so green, blue, brown. Green, blue, brown. One right there. There's one right there. One right here. One right here. So let's do that one first. Yeah. Oh, let's see. Ooh, there's a green, blue, brown right there as well. This, okay, let's just get this one first then. There's that darn 10K that I lost. Brown, black, orange. I'll have to dig one of those out of the drawers, but that's no big deal. Okay. Okay, I think it would be good if the silk screen showed that, but I think, you know, it doesn't show it on the original. So why do that? But he does on the original. They do label the sockets U1, U2, U3, U16, U4, and all that, but they don't. Yeah, so it's not spelled out on the original. So, you know, like I said, it's a replica. So fair enough. Okay. Let's see. Got U2 right up here. That one. Green, blue, brown. It's going to go right here above those 10Ks. Oh, those are 1Ks, not 10Ks. Okay, two more. Two more green, blue, browns. Where are you? I got you. I got you. I got you. Ah, there they are. Right here. I guess I'll be doing the switch pad and the capacitors last. Okay, so here's the red, which is the 2.2. There's a red right here. Wait a minute. That didn't seem right. Now it does. Red, yes. Yeah, you probably wouldn't want to do this while you're drinking beer. There's a little red. right here. You could wind up getting confused and putting something in the wrong spot, and once you do that, it's really hard to undo the figure. You know, once you, I mean, if you stay on track, everything's fine. As soon as you go off track, it's really hard to get back on track. All right, let's see. Here's my. I got 2 diodes and brown black. These are 1 0 0 0 0. Those are 10Ks then. Okay, so where my 2 diodes are going? Got 2 Zener diodes that go here, but these are not Zeners. Ah, there's one right there. And there's one right below it. Here and here are the 2 normal diodes, I guess you call them. They're not non-Zener. And their alignment is with the negative facing west. That's good. All right, brown, black, orange, 10Ks. There's one right there. One down, 4 to go. Come on up. Brown, black, orange, which here and here. And brown, black here, here, and there. Okay. That's 3. That leaves 1 more to go. And the 1 more goes right there. So let's do that one first. That's here. You can see it's coming along. Looks like been going for about 1 hour and 20 minutes. No, not there. Not there. There. Why would you have a 10K feeding into a 10K? Yeah. Guess they knew what they were doing. Again, I don't have the schematic. I'm sure I could use the I'm sure it follows closely along with the actual KIM schematic. The only difference between this replica KIM and an actual KIM is this ROM chip, because and there may be some additional glue logic because of the ROM chip, but on the original KIM, the ROMs here and here were I'm sorry, the ROMs here and here, the 6530s had ROM and even a little bit of RAM in them, but the ROM, so and it was masked, so it couldn't be anyway, it's irreplaceable. So, like, you know, it was a, you know, they're one-off chips, and you weren't going to get them anywhere else. They weren't an off-the-shelf chip. So what they did later on, when they were making, you know, replacement replica KIMs, because they couldn't duplicate these, they just put in generic Riot chips, and then they would put the, you know, the ROM on the outside of the and then they would, you know, just run the address lines to it and add some glue logic so that you could get to it, and problem solved. I think Vince Briel did that first, and it's the only way forward. I mean, if you go back to the PAL, same exact thing. You've got, in his case, he's only using one 6530. If you want the second one, you've got to get the add-on card. And then the KIM-1 monitor, you can see right here is, well, it's 6532, not 6530. And then the KIM-1 monitor is external to the 6530, where it wasn't on the Riot chips originally, which are 6530s, and then so the 6532s are just a generic Riot chip. But the 6530s were bespoke for the KIM. All right. So, that is all of pack 2. Pack 2 down. So, all right, move on to pack 3. 4, pack 3. It doesn't feel very heavy. You got 5 IN914 diodes, 1 BC388 transistor, 7220 ohms. So 220 is going to be, like we know, red, black. 130K, which is going to be orange, black, orange, and 150 ohms. What did we say 5 was? Purple? I can't remember now. So that's going to be black, purple, black. Sure hope I'm right. Let's see. Okay, so great. These new diodes are Xeniers. There they are. There's that transistor. So we got brown, green, brown, which is 1 5 with 1 0. So that's the 150. Is that right? Yeah, 250s. I don't know what I said earlier. And then then we've got red, brown, which is 220. I think I said red, black, but I meant, yeah. So yeah, 220, 220 ohms. And then there's this one off down here, which is the 30K. Let's see if I was right. Yeah, I got that one right. 3 0 with 3, so with 3 zeros. So that's orange, black, orange. So let's find out where this 30K goes first. 30K, orange, black, orange. There, look, there she is right there. Orange, black, orange. Right above those two Xenier diodes, and so that's going to go here. It looks like the Xenier diodes are crisscrossing each other. One is facing east, and the other one's facing west. Which is interesting. Okay, so anyway, well, let's just put those two Xeniers in now. One east, one west. So yeah. Okay. What do we got here? This is the brown, green, brown. You can see there right here, brown, green, brown. So that's here and here. Only two of them. They're a little higher wattage than the other ones. So all the audio requires, for the audio, recording the audio tape requires the 12 volts, and the computer itself and all the memory and the logic and all that, the TTL, require 5 volts. But if you're going to save to a cassette tape, read and write on a cassette tape, you need to have a 12 volts power supply provided, and that's this circuitry down here is all the dark arts of electronics. Vice, you know, everything up here is well, TTL, and the L being logic because it's logical and you can look at it and understand what it's doing, as opposed to having to actually have paid attention in 8th grade electronic class and understood the true electronics, vice, you know, digital electronics, which is okay. That's my transistor right there. This thing about electronics is it hasn't changed. Okay, I still got 3 more of these diodes. I got that crisscross. I got one up here. Oh, you did me the courtesy of, okay. I got that one already from before. Well, anyway, there's one right here. And it's the black band is facing north. Just out of curiosity. Yeah, exact same thing. I guess I could defer to this for, oh, that's interesting. That transistor I just put in is, here it's facing this way, and there it's facing that way. So, if you also look, he's got more logic chips here. See, 1, 2, and you got 1, 2, 3, and then you got 7404. Yeah, so he's got a little more logic going on, and they're down here, and I think that's for decoding for this, because you wouldn't need to add any logic down here because this is all just standard parts you could, you know, off-the-shelf parts. So these additionals, yeah, they got to be for decoding for that, because if you notice, you've got 1, 2, 3, just like we were talking about a minute ago. So you've got your 6502 up top, and then you've got your two 6530s, and here you got a 6502 and a 6532s with this additional ROM, because the ROM originally was masked and put in these special purpose chips, but they're made out of a material called unobtainium. You heard the joke before, it can't be obtained. Let's see. Oh, we've still got to get these, figure out where these more diodes go. One, two, we got those. 3, got that one. I feel like these are extras. Let's compare. There's the 2 diodes there. Oh, and there's 2 more there. What is this? See? See? 2 here, 2 here, and 2 here and 2 there. Right there. Okay, again, these are crisscrossed from each other. top one is pointing to the east, and the bottom one is pointing to the west. All right. Now we've got these 220 ohm resistors, and they're going, how many do I have here? 1, 2, 3, 4, 5, 6, 7. Well, I know 6 of them are going right here. 1, 2, 3, 4, 5, 6. So where's number 7 going? Red, red, brown. Right here. Right there. Okay. Again, resistors have no polarity. It makes no difference which direction they're pointed, except for, to me, it makes a huge difference. I think a lot of other people might feel the same way. I mean, I would, if I soldered one in the wrong way, it would bother me so much that I would break out the soldering gun and remove it and turn it around the right way. And if I couldn't save it when I removed it, and if I couldn't match it with the other ones that were its twins, I would go out and unsolder all of them and replace them with this with like a set of matching ones. Otherwise, it would just drive me nuts. Now, if it's something like on a machine that you don't, it's there for function and not for form, then who cares? But this is form, not function. Well, it's form and function, but. Here we go again. Okay. Yeah, so 1976, when this came out, the Star Wars movie wasn't released yet. I think Jaws was out in 76. I think Band on the Run by Wings was a hit. No, not Band on the Run. Silly Love Songs by Wings was a hit. Probably. What else is going on in 76? Oh, well, of course we had the bicentennial. That happened. And, that was a lot of fun. think the fireworks show on the 4th of July in 1976, because of the bicentennial, was a little more special than usual. Let's see, 76. Well, let's see. There was an election in 76, and Ford lost to Carter, if I remember correctly. And yeah, Ford was a president that was nobody outside of his district ever voted for him. They never, he was the appointed president because he was the VP. What was interesting is he was never, he was a president that most people didn't vote for unless you were from his district in California, and you only voted then for him to be their congressman. But he was a good guy. Let's see, I think I got them all. Alright, let's cut these up. Get the lifter upper out. Get them all pointed skyward so that they'll cut nice. Moving right along. So could this be a first project for somebody to solder together? I don't know, not first project. I mean, you'd expect somebody to have the soldering skills that they might have picked up from working on smaller projects first. I think you might get frustrated. There's nothing here it's all surface mount, and the pads are nice, and it's not too tricky or anything like that. So I mean, you potentially could be for somebody with limited soldering skills. If you're going to drop a few $100 on one of these boards, I think you'd probably want to practice up first on maybe one of those little Christmas light projects that you could get off eBay first, or maybe do a couple of little digital clocks or some Arduino stuff, just a little bit of soldering for. I mean, you want to jump right into this, it can be done. Again, I guess the biggest thing is, besides experience, is making sure you have a decent soldering iron. Doesn't have to be an expensive one, it just has to be one where you can control the temperature, and make sure you've got a good tip, and you keep it clean, and you're using solder that you're comfortable with, got the thickness that you're comfortable with for working. I mean, I use 0.8 millimeter diameter solder, and that's appropriate for this, but some people might feel more comfortable using something thicker. You can, but I think I could move along pretty quick. All right, there's my magnet. Some of those aren't ferrous. Okay. All right. Get rid of this stuff. Keep your work area only as cluttered as you are comfortable. All right, pack 4, 6 transistors, 1 megahertz crystal, 1 10 picofarad capacitor, and 1 330,000 ohm resistor. So 330,000 is going to be 330. So it's going to be orange, and that's 33, and then how many zeros? 33000. So is it going to be orange? Yes, it's going to be orange. I called it. Orange. Oh, orange, yellow. Well, why is that? 4 zeros. 330000. So I didn't call it. I was off by a magnitude of 10. That's pretty bad. Okay, I could have. All right, so let's figure out where this 330 goes first. Running out of places to put resistors, so that's a good thing. Orange, yellow, where do you go? Orange, red. That's already in there. Orange, red. Orange, yellow. Come on. Well, instead of looking on here, why don't I look on here? Because that doesn't help one bit. That's why. Let me look up top. Orange, yellow. There she is. And this funny looking capacitor, why do you pick that? Is that authentic? Is that consistent? No, it's not. There's the little weirdo capacitor, but no biggie. You're gonna go in just like that. Here's my crystal. Pretty sure it goes here. Let's double check. Yeah. I like that can capacitor. Oh, 1, 2, 3, 4, 5, 6. They're all going right here because these drive each one of these is triggered by signal to the base, which is current limited by these resistors, and in case you didn't know, at any given time only one display is actually, one LED display is actually on, but through a magic trick known as persistence of vision, it appears they're all on at the same time because your brain and your eye cannot keep up with the speed that it is flashing. So your brain and your eye just decide that they're all on at once. And that's how you can drive a calculator display or any kind of display with the minimum amount of hardware, and you just the multiplexing is managed in software, so you save on parts. And all right, that is all of number 4. Fine, let's start soldering. Multiplexing is also easy to troubleshoot. It can tell you a lot about what the software is doing while you're troubleshooting. 'Cause as long as you understand what it's trying to do, and then when it's not happening, it makes sense. The other thing about multiplexing is you wear out your bulbs much. They last a lot longer because they is that it? That's all of it? Okay. Yeah, they'll last longer because they're really only, if you've got 6 bulbs and they're multiplexing, you just increase the life of your LED by 6 because it has a duty cycle of just 1/6 of the time that it's actually on. So it'll last 6 times longer. Snip, 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 and snip, snip. There's the magnet. Clean up. Oh, not ferrous, not ferrous. Got a couple ferrous, but all right. Oh yeah, she's moving along pretty quick. Nice and straight. This is good. That was pack 4. Pack 5. Capacitors. Well, these should be easy to put in on account of they're all color-coded. So what's interesting about this rheostat, or potentiometer, or whatever we want to call it, is the KIMs, each one was individually set at the factory, and once set, you never have to adjust it. But there's a little program that you can run on your KIM. You enter it in, and you do some kind of a playback loop or whatever, and then you can trim this and adjust it until it's not too high and it's not too low and it's just right. Okay, so this says I've got 3 of 0.22 microfarad capacitors. These are 220s, not 0.22s. Jeez. Must be this though. These are get these all 104K to 2014, whatever that means. Got 4 of the same, 5 of the same. That makes sense. Those are 1 microfarad, 1.1 microfarad, 3.22s. Let's assume it's that one. And we've got a 1, 2, 3, 4, 5 of those, 3 of those, 3.0068s. I'm not seeing that. Okay, whatever that is. 223 K, whatever that is. This is a one-off 33 microfarad. Is that 30 microfarads? 0.33 microfarads. 6800. That's this one. Okay. It says 3 of them. Oh yeah, 1, 2, 3. 1, 2, 3. These weird little can capacitors, and then we've got 2 of these axial, meaning it's like an axial style caps that are 10 microfarad. Oh, 1 microfarad. All right, so let's do this. Let's start with these 3 weird can shapes. And I wonder if they're polarized. They don't appear to be because there's no marking showing their polarity. And they're not in the picture. All right, let's cheat and go here. There's that style right there. There's only one like that. Okay, well, let's just go with what we know. Here's the 6800 right here. And that was a one-off, wasn't it? 600. Two, 3. 0.33. 1000 picofarads. Come on, show me the 6800s. They're 10s, 220s. Alright, fine. We don't have the 6800. Let's go with that. Oh, that's a 68. That's a 68. How many 68s did we have? 3 68s. Okay. 0.0068. So, alright, so fine. 1, 2, this one. This one and this one are these ones that don't quite match the picture, but it's not a deal killer, is it? Apparently, no polarity. Okay. These are some weird capacitors. Again, they are axial in style, and well, they're weird. So that's that one, that one. We'll give up on that one for now. So let's put that one aside. Let's go here. Now this has got the okay, 104, 104K, and 104K here and here. That's these guys. Remember there were 5 of them. Let's get this right. Again, no apparent polarity. But apparent polarity in these. But okay, so we got those two. I feel like we've done this entire upper end except for these digits. On blue can, which is actually here too. So I'll put the two blue cans in. Okay, this one is polarized with the negative facing north. And this guy has the negative facing north also. Big fat one here, 250 33 PF. That's this guy right here, remember? Yeah. These caps are moving along pretty quick. Okay. That's a 220. I don't know where he got these old school caps from, but they are very authentic looking. I mean, yeah. All right, this is the 104K. That's this guy right here. I mean, the modern caps for these sizes we're talking about would be much smaller. These are, we're talking pico and nanofarad sizes here. These are just, you know, paper wrap with a little foil in them, but I mean they're really been miniaturized over the years. Let's see, this is this little chubby one here is 223. Probably this guy right here. Yep. Okay. And this horizontal one is a 104K. Okay. Okay. All right. This horizontal one's a 220. Yeah, I'm gonna love to ask this guy where he got these old caps from. He must have found a limited supply somewhere, somehow, or something. You'll never find these again, or you'll never find them in reliable amounts. I know that. Let's see, come on. Come on. Come on. Don't fight me. Don't fight me. Okay. Oh, let's see. A 150. Both 6800s. So I need two 6800s. I think. Let's see. Well, that's a 104. Oh. Where I did that. So 150. 220. 473. Come on, 150. Where are you? This must be this guy. No, it's 1,000 picofarad. Oh. I found out where this third one goes. It goes right here, along with his buddy. Yeah. Okay. That's the 1,000 PF. And the 220. These are a little the gauge on this wire is let me ream this out a little. I'm afraid if I pull on this too hard, I'll damage the let me pull it out. I'm going to snip off the end on this, and maybe this one. This is a really tight fit. In fact, too tight. Let me just double check and make sure I'm doing the right thing. 220. Yeah. So get in there then. Okay, that one will go. So just don't want to, you know, put something in a hole it shouldn't be there. Okay, all right, well, you're sticking. All right, I got you through. Let me pull you the rest of the way. Boy, that was not easy. Okay. I'm sorry, I just had to just grab onto it with the not pinching in. Okay, pull up a little more. Yeah, let's see. All right, that was not easy, and I would recommend being very careful with that. Okay. What do we have here? That's the 1K that's missing. Also interesting that the hole got soldered. Did I do that? I'll look into that later. All right, I got 2 more of these caps to go, so let's see. 104K. That's this one right here, right there. Last but not least, 473K. Where do you go? 473. Right here. All right, that's all of them. Start soldering. Okay, I think I got this one right here. Did I get them all? Yep. Stander upper. Two hours and 9 minutes. Oh my goodness. This is... And I haven't even populated the ICs, the sockets yet. Oh. See? Missed one. All right, start snipping. We missed another one. I hope I didn't hurt a trace when I was yanking this baby through. That would be it. I'll have to keep an eye on that. If there's trouble, that's going to be the first place I look for it. From me manhandling that wire that wouldn't fit. And I guess I was trying to leverage the part through when I was doing it while I was pressing against what looks to be like a pretty delicate trace. Let's look at that again. That's irrelevant. This, well, just tone it out. Make sure we're okay. Can you hear that? Okay. So this goes to the middle one. Let's see. Yeah, this one. You should make it to here. No. Really hard to follow this. I got that right. Ah. Should make it to here. Beep. Okay. Wow, that is one long trace of zigzagginess, but I don't know if you can hear that beeping sound, but that's telling me that the trace works. Now, let's just make sure it didn't short over to any of these other ones, and it didn't. I think we're going to be fine. Yeah. Oh, let's see. Okay. I think I'm going to do these next. And other than a reset button, I'm going to do the pad last. I'm going to put these on there. I'm going to fire up the reset button. I'm going to find a 10K resistor, and when I'm at it, I'm going to clean up this little mess I made right here. There we go. That 10K resistor that I lost and rolled around here somewhere, it's just going to have to come out of the you know, stuff just goes missing. Not much you can do about it. But anyway, I will replace that with one of my own. And when I keep saying 10K resistor, but I don't remember if it was 10K or 100K or whatever. But I will make sure that I replace it with the proper part. Okay, let's see. Brown, black, 10. Is that an orange? No. Red. So 1000. So that is it's a 1K. I'll get that in a minute. All right, these babies. Where are you? I guess it doesn't need to be said, but the dot down. So the decimal would indicate the down. You could potentially put this in upside down, because the way the holes are drilled. So dot down. 2, 3, 4, 5. All right, let's again, just like I did on the other ones, I'm going to solder. In this case, I'm going to solder in one pin and make sure it sits flush by pressing on it. There we go, letting it cool. That should do it. One pin. There we go, let it cool. Okay. Nothing could be worse than having these digits crooked in their sockets. So, and nothing is more difficult than after you've soldered in all 14 or 16 pins and realize that it's crooked, and then have to go back and fix it, because you're going to wind up destroying it in order to fix it. But no, this baby is straight. Look at that. It's starting to look pretty good. Okay. Starting to look like a KIM. Okay. So these are the 7-segment displays. If you don't solder it, you know, if you miss a pin or something like that, you'll know right away. One of the segments won't come up. Maybe the whole thing won't come up if you didn't do the ground. You know, but you've got the other 6 to compare it to, and it'll be easy to circle back and find your mistake if you made one here. Come on. And what could cause a 7-segment to not work when the other ones are working? Well, it could be that one of the 6 transistors, if the whole thing's not coming on, or one of the segments isn't coming on. It could be and it's only on, say like the middle segment wasn't working, but it wasn't working on all 6. So you would think, well, this is multiplex, so the problem goes back to it's not, the problem's not in the in each individual display. It's going to be upstream. You would go find the say the resistor. Remember, we were doing these earlier. You would find the resistor that's associated with that that piece of segment, and you'd make sure it was soldered right, and then you would trace the line back to whatever was decoding it, and then you would compare. Those are done. And you know, that's yeah, that would be an easy problem to solve, as opposed to I plugged in, I gave power in, nothing happened. Okay, well then, you know, the troubleshooting is a little more black boxy than something where it's actually telling you something. But if you plug it in and nothing happens, well, make sure you've got power to the power pins. Maybe you just need to hit the reset button. Nobody told you that, but sometimes you know, you got to reset it to get it to, just powering it on is not a decent enough reset to get it going, or who knows. So those things happen. It's just waiting for, I mean, you know, like with a KIM-1 board, you have to hit reset and another, I think clear even, to get it to come up to get it to respond. So if you just give it power, a lot of people think, oh, there's something wrong with the board. I hit reset, nothing's happening. No, there's on a KIM-1 board there are two pins you have to hit in sequence. No, sorry, buttons in order to get the monitor to display the fact that it's working. Okay. Let's see. Yes. Clean up, clean up, clean up. All right, a little prickly, but not too bad. Feeling pretty good. Let me hit pause while I find that 1K resistor. Alright, I found a 1K resistor. Everybody should have that value of resistor in their scrap box. It's a good thing it wasn't one of the oddball sizes. I might have to dig a lot harder to find that. Okay. Alrighty. So the AWOL 1K resistor is can remain AWOL because I have replaced it. So I'm going to socket these, apply, and put the reset button on. And I'm going to apply power and hit reset and see what happens. So resets this one right here. And it should when I do that, it should anyway, it should respond. Oh, it's a good feeling click. I like that. With well, at power on, the RAM's just going to have random data in it. So it's whatever the program counter is, which will be random data, is going to show the contents of that random it's going to be a random address with random data, but it's going to show up and after hitting reset. So I got the reset button on there. I'll populate these chips and then and restart again. Hold on. Here we go. Okay, here's the 6502P, which is going here. A little dinged up. It's just a little dinged up, but these look brand new. Make sure I didn't mash any pins here. Looking good. Get in there. Get in there. All the way. Thank you. Alright. Alright, RAM. 2102s. The hard part's going to be these ones because they're all down here and I got to figure out what's what, right? You know. 1, 2, 3, 4, 5, 6, 7, 8. 2102s. Get the alignment right. They are pointing east. Seem to be going in quite well. It must be hard to source or find a reliable source for these obsolete 2102s. You know, if you're making one or two of these boards, it's no big deal, but if you want to produce a lot of them and sell them on eBay, and you know, you better have a reliable source of these obsolete parts. So clearly he has them. So speaking of which, see, that's the thing about it, about this, it's so authentic. This this KIM-1 replica is 1K of RAM, just like the original is 1K of RAM. Each one of these is a bit, and there's 1,024 bits in each one. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's that. Well, if you notice on the Corsham and the PAL, the Corsham's got like 32 or 64K, and this one's got 5K of available memory on the bare board, and of course it's expandable to the full 64. But but it's, so when they designed this, they just went ahead and said, you know, it's using more modern parts, we can put 5K on there and not use these obsolete parts. But if you want authenticity and you want a drop-in replacement, this is the way you go. So every one of these replicas have their own what's the word I want to use? They have their own merits. And so now I need to figure out which one goes here, which one goes there, but you really can't make it out on here. You can't read that, and these aren't labeled too well. So, well, I don't know how other people are going to do. Oh, what do you know? The back side tells you what's what. Oh my goodness. I wish I knew that. U14 and U13. Well, this is going to be so much easier. Okay, U14, well, that's just quantity. Okay, U1, U13, U14 is number 9. And number 9, well, wait a minute. How do I crosswalk the fact that U13 and U14 are item number 9? And I have the quantity here. Oh, I see what it is. Okay, I'm sure we can just crosswalk it like this. Okay, yes, it's 2 74LS 125s. Got it. Okay. All right, eyeballs work. 74LS 38, 138, 0000. 145, 145, that's U4 and U24, but I want 125 and 125. Here they are. Okay, and these guys are facing south. Come on. I don't want to bend a pin. So go in there. There you go. There, I'll just pre-bend them a little. All right, this guy. Wow, I can't believe I have this chart here in front of me that was right under my nose. U17. U17 is a 7406 hex inverter. 7404, 7406. Yeah, I'm not surprised that I didn't bother to flip that thing over and figure out something that was completely obvious. Of course, he's got a way to map these things. I'm not surprised I didn't figure that out until later. I'm also not surprised that he did it, because it makes this just goes to show the attention to detail that we're working with here. Okay, so let's get these. We'll start over here. U29, U28. Come on, U29, U31, U32. Come on. Let's see a U28. Ah, U15 and U29. Line 10. Okay, so 7400. Which is probably quad AND gates or quad NAND gates. I can't remember. I can look it up. Make sure I have that pointing north. U29 points north. U30. U31, 32. U30. 7404. Again, quad gates. I couldn't tell you off the top of my head if it's AND gates, NAND gates, or whatever, but you'd think I would know that stuff. U30, pointing north. But, I mean, I do have the TTL cookbook right behind me. I could open that up. But U31 and U31 is painting north, and U24 is south. Let's go to U31. U31. Sim4 LS138. Let's see, the Sim4 LS38. No, 138. Yeah. And this one is pointing north. Okay, pins should fit comfortably. My fingernails to kind of get them in there. Come on, guys. It's not that hard. It's going to be your home for a while. All right. Next up, U24, which, by the way, is pointing south. Sim4 LS145. Okay. U4, which points north. Sim4 LS 145. U15 74LS00. There's an 04. Rutrow. U15 74LS00. Oh, I just did that one. Yeah, see, that's why we have to pay attention to what we're doing. Because I got that wrong. Get the right piece. Yeah. Come on out, baby. Come on out. You're close to home. You're just off by one. Okay. Okay, get in there. Mm-hmm. You feel like you're in place. But let's wait a minute. Yeah, U15, U16 point north. Okay, so let's go back to U16. U16 is an 04. 74LS04. Kind of bend those pins in just a smidge. There we go. Okay, these two guys, 26 and 25. Let's start with 26. Oh, by the way, they're facing south. U26 is a quad NAND 74LS38. Seven 404 74 LS38. We said it was facing south, right? 26 faces south. 26. Get this right. 26 is a LS38 quad NAND facing south. 26. There you go. Getting near the end here. 25, also facing south. That's the 556, which is a 2555s on the same package. 8610, what is that? Okay, 556. Again, facing south. Bend these pins in just a smidge. It's funny, I remember the 555 timer in the 80s was a pretty big deal for us. It was, you know, it's an IC that you could get at Radio Shack, and it made sense, and you could understand it, and you could trick it into being an amplifier. You could do all kinds of stuff with a 555, and it's a bulletproof little chip. It's great. It's been around for years, and people are like, "Oh no, you can just get a PIC to do that." I'm like, "Why? 555 works just fine." This guy, U27. U27. U27 is the 565 phase lock loop, which I have no idea what that is. But here is a 565. And go back to 27. 27 points north. What on earth is a phase lock loop? I don't know. But I'll tell you, it's got something to do with the audio. It's right here next to the rheostat, which is next to the op amp. So some kind of a, like again, not a TTL chip, some kind of dark arts that, for people who really know their electronics. U28 faces up. Actually, I am curious. Is U28, is he using, yes he is, he's using the same, he's labeling them the same as they are on the board. Of course, obviously not for the ones that are add-ons, but yeah, so U24, U24, yeah, so he's being consistent, so that's cool. Alright, what do I have left? I don't see any spare sockets. So what do I have left over? I have a leftover 7404 and a leftover Max 232. So pretty sure those belong. Oh, and that makes sense. That's why we have those two extras from earlier as well. I'm pretty sure those belong with this, which is the little kit that you get that has, yeah, that's exactly what that is. It's the power TTY and cassette add-on kit, which I'm not going to do tonight because we're just, like I said earlier, we're going to power the old-fashioned way. So look, it's assembled, not including the keypad, but I just want to make, I'm going to give it power, and I'm going to hit reset, and we should get something that makes something sensible on the screen there. So okay, it's important that you know that this thing takes 5 volts. It is not, there's no LM7005 on here to, you know, to regulate it or anything like that. So if you throw 9 volts on this board, you will fry it. So remember, whatever you're doing, it's 5 volts. And here we go. Don't throw 6 or 9 or anything at it. It's a 5 volt board. Oh, something. Oh, what do you know? Okay, Alexa, turn off work light. Look at that. D70600. So, you know, hit reset. Okay, so that's what that's telling me is the program counter, you know, the RAM, which at power up has random in a random state. So the it thinks that the program counter is pointing at D706, and the contents of D706 is 00. So this is a very good sign. I am going to solder on the rest of these and see if I can enter data. Alexa, turn the light on.
A couple things share that name. Work light and work light.
Alexa, turn on work light. So give me a few minutes and I'll put these on. Power off. That is exciting. I mean, you've been here the whole time. You saw me. I didn't cheat by going off camera to make sure it worked before going back on. We were here together the whole time. And so basically, it worked first time. It's just pretty much academic at this point that the rest of it will work, because if we got this far. Now, we haven't tested and trimmed this, the tape recorder part, That will require, like I said earlier, to tune the to tune that rheostat so that it shows the so that the volumes are just perfect. But that's a set it and forget it. And in the old days, it was set at the factory, and you never had to change it. Well, we're the factory, so we're gonna have to set it. But I will do that. There's YouTube videos out there of somebody explaining how to do that. But basically, you load the program in there, and the digits will show like all sevens if it's too high, or all sixes if it's too low, and you just keep trimming and trimming until you get all zeros, and then you go, and then that's it, you're done. Look at this. I mean, I'm going to solder these on super quick. They better be straight though, because there ain't nothing worse than crooked buttons. But I'll solder these on super quick, and that's for single step right there. Put that in. That's going to fall out, so I'll put that in last. Make sure these are all in nice and good. Just like all the other things, I'm just going to do one pin first and flip it over, make sure it looks good, and then do the rest of the pins and clean off the way out. There you go. Oh yeah, I'm starting to get a little excited. KIMs are going for $1,200, $1,600 for a good one on eBay. I mean, that's a lot of money. I mean, even an original Commodore PET from '77 is, pretty darn rare. And they don't go, and there's a whole lot more sophistication to one of those than there are to one of these things. And it's also arguably more useful. And they don't go for that price. So, well, they go for about that price, I should say. Let's get this in. Now that it's in, I'm going to push up from the bottom while I warm it up, make sure it's straight. Okay, now let's look at these and find any of them that aren't straight, like this guy right here. Okay. Or this guy right here. Okay. All right, come on. Are you straight? Straight. 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 Because there ain't nothing worse than crooked. All right. Lock them in. I'm going to lock them in. Power it up again. And see if I can enter data. Then everything else is cosmetics. Putting the little button pads covers on, and oh goodness, this will be a 3-hour video. No doubt I will be putting this up at like 10x speed, so you'll just hear like a high-pitched voice. I might even take my voice out completely and just, I don't know, run some 1976 disco music or something in the background. Something from the Earth, Wind, and Fire, because that's what 1976 was. And but anyway, this is going to be done in one take. You are beautiful. All right, let's see if we can actually enter data. Preset. Uh-oh. Okay. Too bright. Too bright! Alexa, turn off work light. Okay. Address 0000 there. And then let's change 000 DA. Funny, I memorized where this stuff is, right? Change that to FF and then plus FF plus FF plus, and let's go EE plus, and then DD plus, and CC plus, and then go address 0000. There's FF, EE, DD, CC. It's great. It works. Okay, so I could even write a little program in here. But we don't have time for that. But I was thinking of I'll probably do that later. Make it say foo-foo or foodie or beef or something. It's easy enough, and that's a good test. Let's see. Well, I guess I'll put this on the cover, mount it, and then put the little button caps on top of that, and oh, dang, going great. Alexa, turn on work light. Alrighty. Let's see, these little plastic standoffs. In the picture, which way are the screws pointing? Where'd my picture go? Here it is. Okay, it's got the slot screws up. Okay, so simple enough. I just have to do that 4 times. I don't know. I think I would want to upgrade these to brass, but there may be plenty of good reasons to use the nylon. And in this case, and that's probably because the original keypad, A, wasn't all that good, and B, would be impossible to source. He deviates a little, and has this keypad, which is, again, it's going to be a drop-in replacement. It is the dimensions are just a little different, and we'll see if that makes a difference or not. Oh, damn it! Think. Okay. Gravity. Gravity is your friend. Alright. Okay, put these little itty bitty bolts on. Or nuts, I'm sorry, itty bitty nuts. Alright, so the only fiasco was I dropped a resistor, but fortunately it was a common size, and I had a spare. Actually, many spares of a 1000K resistor. So there was that, and the fact that I almost ripped up a trace, but apparently you know, by being careless, but that was because the leads were too fat for the holes. So feedback for the designer. That probably want to have those holes widened a little bit when you do revision 1.3, and that would be for this capacitor here. Yeah, the and we're just talking microns of difference. Okay. Dang. Oh, clock says 2 hours 57 minutes. Let's get this done in. Let's get this done in 3 hours and call it a night. You know, okay. Yeah, a little single step button over there is a little cheesy, but I mean, how many times you actually got to flip that? All right, reset, reset, reset. Why do I got to keep hitting reset? Okay, what am I doing wrong here? Alexa, turn off work light. Okay, address 0000, address 00, reset, address 0000. All right, what have I done? Nope. What have I done? Reset, address 00. Oh, sorry. Reset, address. Something I did. Make sure these are all settled in good. Check my power supply. Yeah, I don't know. Okay, so address 0000, it's got a 40 in it. DA, change that to AA, plus BB, plus CC, plus DD, plus EE, plus FF. Okay, I'm not going to actually program this thing right now, but then reset and then go to address 0000. There's AA. 41. There's BB, CC, DD. I must have double pressed the plus button. So it's working. Take a look. Reset, address 0000. There's AA, just like I put it there. And then BB and O2, CC, DD, E, FF. So reset 0200, and then say 0200 A9, A9. Oops. Reset 0200 DA. Okay, A9, which is load the accumulator with F0. Yeah, F0, and then plus, and then let's say jump subroutine. Oh no, we have to store the accumulator 85 in zero page FA. So 85, 85. That's not a very good. I'm going to check that. I have to check my which resistor I got that's in charge of that little pin down there, but I'll get that. So 85, store the accumulator in location FA, no, F9, and then store that same thing, 85, into location FA, and again 85 in location FB. So F9, A, and B have F0 loaded into them, and then I think jump subroutine is 4C to 1F, 1F, and then did I do that right? Hold on a second. Address 0200, make sure I got this right. Load accumulator FO, store accumulator F9, store accumulator FA, store accumulator FB, jump subroutine 1F, 1F. Okay, yeah, I did it right. All right, and then 40. Okay, address 0200, E9, F5, F9, A5, F5. Okay, 85, FB. Okay, 4C, 1F, 1F, DA, 40 plus 00 plus 02. So that's jump back to 200 plus. Okay, then I'm going to say address 0200. Well, it should say FO, FO, FO. Actually, FO, 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 because this is the memory location F9, FA, FB. Go. Reset. A9, FO, 85, F9, 85, FA, 85, FB. Okay, then 4C. I think it's 40. I'm mixing up jump subroutine and so this DA 40 to 1F, 1F. Then 4C to 0002, which is 200. Okay, address 0200, go. Well, this is not the machine's fault, it's my fault. Single step on? Dumb. Okay, reset 0200, go. Okay, and then FO. That's good. That's not exactly what I wanted to happen. I wanted it to happen while it was running, not when I ended it. I think that's anyway. I'm not the greatest programmer in the world, but fo proves this is programmable, and we did good. This is a KIM. This is excellent. I'm going to stop recording now. Alexa, turn on work light. Let you guys take one more look at it. The only concern that I have, and I'm going to have to check my my soldering, is the segment down here, which is A, B, C, D. Segment D is dim, and is again it's dim on all of them, which means it's not the fault of the transistors, which are basically the switches that are turning them on and off, and it's not the fault of the 7-segment displays, because it's the same problem on all of them. It's probably the wrong value resistor, 1, 2, 3, 4, 5, 6 of these 7, but they're all the same, so it can't be that. Or it could just be, so if I was to go 8888 address 8888, I don't know if you can quite make it out, but this bottom segment it looks more like an A than an 8, right? Because the bottom segment's not lit. It's one of these that's the problem. And I have to go and trace it out. That's it. Thank you much, guys. Work first time. Okay, I fixed that bottom segment. All I did was warm up the joints on these 1, 2, 3, 4, 5, 6, 7 resistors, and we are good. Look, here's 8888. They all look like 8s. So that's good. One thing I can do, and I will do, is put a piece of red. Here's an example. Red filter across that, and you're just doing the top versus the bottom. And I don't know if you can see it, but what it does is it makes the segment more red and less orange, and it becomes much more readable. So I suggest you do that too. But to do that, you need to have a spool or some kind of red filter tape that you could use, or maybe a piece of red plastic and experiment around. But I use this stuff, but it's for 7-segment displays, and it's for example, I did it right here on the PAL, and it makes it nice and bright and readable in the daylight. So you don't have to turn out the light when you want to show things to people. But this is fabulous. I did this in 3 hours. Worked first time. It is a real KIM. You'll love it. I highly recommend it.